It's the clock is worked by an electric wire from Dunsink. Must go out there some first Saturday of the month. If I could get an introduction to Professor Joly or learn up something about his family, that would do too. Man always feels complimented. Flattery where least expected. Nobleman proud to be descended from some king's mistress, his foremother. Lay it on with a trowel. Captain Han goes through the land. Not go in and blurt what you know you're not to. What's parallax? Show this gentleman the door. Well, I think that's a poignant passage, because Bloom is always the outsider, but here he is an outsider to the world of science. Dunsink is remote to him, and further remote is Professor Joly. I'm glad to say that in 116 years things have changed a lot, and Dunsink is accessible to people all over the world tonight, and the Dublin Institute for Advanced Studies has a great programme of public engagement and have been running a great series of lockdown lectures. Now, I'd like to look at some of the maths references in the Ithaca chapter of Ulysses. Some of the passages read so well by Barry McGovern. It's such a treat to hear him bring it so alive. And I'm going to pick on a few of those sections and look at them through mathematical eyes. Pythagorean sesquipedalia of the Panepistimion. I'd like to thank Des Gunning for that title and thank him for making me attempt to pronounce it publicly. It comes from Finnegan's Wake, and like a lot from Finnegan's Wake, I find it difficult to understand. The Pythagoreans were a cult that believed in the magic and significance of numbers. Sesquipedalian refers to the use of polysyllabic words, a kind of bombastic or long-winded speech. And Panepistimion refers to a place for all knowledge, which may be a university. So it's an apt title, though, for an investigation into this section of Ithaca, where Joyce and Bloom and the interlocutor have a great fun with very large numbers. The biggest of which is the incalculable trillions of billions of millions of imperceptible molecules contained by cohesion of molecular affinity in a single pinhead. Well, let's look at this. He's talking about trillions. That's 10 to the power of 18 by billions by millions. And that is 10 to the power of 36. So that's a pretty big number. And too big, I'm afraid, for the number of molecules or atoms in a pinhead, which would, for a 1.5 millimeter diameter spherical pinhead, I calculated to be around 10 to the 20, which is a long way off. Had he went for thousands of millions of billions, he would have been pretty much in the right ballpark. But this isn't giving us the final answer, because the next question is, why did he not elaborate these calculations to a more precise result? So maybe he would have checked his figures had he not been learned of the existence of a number computed to a relative degree of accuracy to be of such magnitude and of so many places, e.g. the 9th power of the 9th power of 9, that the results having been obtained, 33 closely printed volumes of 1,000 pages each would be needed to write it all out. And let's look at it here. 9 to the power of 9 to the power of 9. Well, we can calculate 9 to the power of 9 on our calculator easily enough. 9 to the power of 9 is equal to 387,420,489. A big enough number on its own right. Try raising 9 to the power of that, and you'll find that neither your calculator nor your computer will be too obliging. But we can figure out how long such a number is, and we can use logs. So for instance, log of 100, the log base 10 of 100 is equal to 2. So if we take the log of a number and add 1, we get the number of digits in it. So how to take the log of 9 to the power of that is equal to 397, 420, 489 times the log of 9, and that will be 369,693099.63. We add the 1 and we will be 369,693,100, and that tells us the number of digits in this fantastic number of blooms. And if we divide that by the 33 volumes he claims it would require, we will get 11,000, I'll write it up here, 11,202,821 characters per volume, and we have 1,000 pages in each volume, so that would be 11,203. We would need to be able to print 11,203 numbers on each page, and he says it's closely printed. So can we closely print it? Well, we can, yes. This is printed with 8-point font, perfectly legible, small but still legible. And if we do a word count on it using Word, we'll find that we can indeed fit 11,203 words. So it is perfectly possible to contain the number 9 to the power of 9 in 33 volumes of 1,000 pages. So Bloom and Joyce were on solid ground here with this particular claim. Elsewhere in the Ithaca chapter, we learn of Bloom's schemes and dreams to get rich quick, and we'll take a look at a couple of these. A contract with an inconsiderate contractee for delivery of 32 consignments of some given commodity in consideration of cash payment on delivery per delivery at an initial rate of 1/4 pence, to be increased constantly in the geometric progression of 2. That is 1/4 pence, halfpence, penny, 2 pence, 4 pence, 8 pence, 1 shilling, 4 pence, 2 shilling, 8 pence to 32 terms. Well, we can calculate that reasonably easily, and that will earn Bloom 8,947,848 pounds, 10 shillings, 7 3/4 pence. That is assuming he can find somebody with the financial capacity and the lack of mathematical capacity somewhere around Eccles Street to oblige him. Now, he also talks about a prepared scheme based on a study of the laws of probability to break the bank at Monte Carlo, and the solution of the secular problem of the quadrature of the circle, government premium £1 million sterling. Well, unfortunately, the quadrature of the circle is impossible. That is being able to construct a square equal in area to a circle, and there was no government premium anyway of £1 million sterling. But Joyce was able to make fun using maths and science in this episode, and do read it, enjoy the fun he has and the certain cadence and rhythm to the scientific and mathematical language therein. So I'd like to thank the Dublin Institute for Advanced Studies and those organising this event, Darina and Des and Luke, and I'd like also to wish the Dublin Institute for Advanced Studies a very happy 80th birthday.